Hello. Can you hear me okay? So, hello, thank you so much for coming. It's really nice to see some familiar faces. My name is Diane Ortiz-Macleod, and I'm so excited to be today and share with you about the tools I helped develop alongside a great team with farmers, helping them get the most value out of their fields. Sometimes we take for granted the food that's available to us at our favorite restaurants or favorite grocery aisle. What we've seen recently is that farmers are struggling to fulfill contracts with food manufacturers. And so food manufacturers then struggle to fulfill orders with retail and other end customers. So the tools we developed are helping farmers, using real data, gain insights about what is the possible crop and yields to come out of their fields. It's a machine learning model pipeline, and it provides farmers with the best times to harvest their fields. I think it's such a cool project. So I work for Fiddlehead Technology. We're a data science consultancy in the FMCG industry, so that's fast-moving consumer goods. Specifically, we work with food and beverage companies, helping them with AI tools in prediction, simulation, and optimizations. And how did I find myself here? I'm a math nerd through and through. So with a statistics background, I've always enjoyed analytical thinking and logical problem solving. And currently, I live and work in New Brunswick, Canada. So this is a really, really small province in Canada. It's north of Maine, the state of Maine, and it's just by the Atlantic Ocean. So I actually was born and raised a city girl, but I never would have guessed that I'd enjoy living the rural life so much. Essentially, we're surrounded by farming communities. I love my community. In my free time, I can be found doing art or volunteering, sometimes both at the same time. So I founded a program that teaches art to people with disabilities, and 6 years later, we're still operating entirely volunteer-led. If anyone was able to become familiar with Women in Data this past week, I was one of the artists that helped create the first ever NFT collection. So this is a really incredible initiative with Women in Data that's helping bring more accessibility to women in the Web3 spaces. So I think that's super great. That's me, math and art geek. Okay, let's get back to the problem. So at Fiddlehead, one of our major partnerships is with McCain Foods. McCain Foods is the global leading manufacturer in potato and prepared food products. They're home to a team of 22,000 people in over 160 countries. In fact, there's a good chance that the French fries eaten in Vegas this week, 1/3 of them are McCain food products. What McCain is noticing is that with recent unprecedented weather events, which is a common theme I've noticed with some of the other presentations this week, unprecedented weather events are disrupting business, major storms, major droughts, farmers are not fulfilling their contracts, and McCain is unable to meet demand. It affects food availability for you and I. So if we think about the food industry, where is the start of the supply chain, the root, if you will, without a doubt, it's in agriculture. And so all of the other tools that we develop at Fiddlehead along the supply chain for making more efficient storage, production, shipping, and sales, they're actually all of absolutely no use unless we can farm the food that feeds the world. I'd like everyone to meet Jeremy. Jeremy runs a family-owned farm in New Brunswick, Canada. Jeremy's recent pressing questions are, how will these weather events affect my crop? And when is the best time to harvest? So Jeremy has numerous fields of crop, but limited resources in machinery and labor. And so the tools that we're developing with farmers like Jeremy and McCain are providing a solid base for all the other challenges that we see throughout the industry. Actually, ag tech has seen lots of recent advancements. Like, it's really incredible what's going on in the farming industry right now. In terms of crops specific to potato, it's not as robust yet. So to start approaching this problem, we don't want to, or we didn't, drastically change the infrastructure of Jeremy's farming operations. It's another thing that I've seen throughout this week. It's about augmenting decision-making processes with tools as opposed to replacing them. And we identified a group of stakeholders. So we have a steering committee, chief agronomists, agricultural specialists, satellite image specialists, meteorologists, and technical teams like my data science team and our engineering team. And these industry experts are helping lead the project. We identified a common goal among the industry experts, that's sustainability and cost efficiency. So we took an agile approach. Each business decision was made collaboratively before moving to the next step. We met very frequently, weekly, often daily, and we actually didn't only meet virtually, we met face-to-face too, so we had our hands in the soil when we visited farmers in their fields. And it was from farmers that we learned that this tool we're developing must be a mobile app. So this tool is supposed to help them during harvest season. They're so busy during harvest season that they need to be on the go. It has to be a mobile app. Every farmer knows the grind of harvest time. I actually met a couple of people that come from farming families this week. So there's 2.2 million farmers in North America. Every farmer and their family and their friends know the grind of harvest time. The entire growing season leads up to this short period of crunch time where crop is at its peak and it needs to be harvested. But with climate change, farmers are saying, I can no longer rely on my expertise and my intuition to know the best times to harvest. So even a few short days can make a really big difference. That's why we have our industry experts and their respective data on board. Okay, so what was the data that we used? We used data on weather, satellite images, soil conditions, as well as field management practices, so herbicide use and pesticide use. We use these to understand how these factors affect the growth of a potato. And through a crisp DM process, we spent numerous hours understanding the data, cleaning it, going back and forth with our industry experts, doing feature engineering, and ensuring that there were no known gaps along the way. So this data was used to develop our models. It's years of historical data, and it's a machine learning model pipeline that consists of 3 models. The first 2 models, I'll add that it comes out 1 month prior to harvest. So the first 2 models predict yields and quality. So it tells a farmer, this is what your expected yield and quality of crop is on this day in the harvest season. Now the harvest season is actually up to 45 days long in a lot of cases. So from a day to 45 days can make a huge difference of what comes out of their fields. And that's where our third model comes in. It's an optimization algorithm that we developed at Fiddlehead. It takes in the predicted harvest along with costs associated with operating machines and weather forecasts, and tells farmers this is the best sequence of which to harvest your fields and at which dates specifically. So within a month, farmers have enough lead time to act accordingly and get the most value out of their fields. And McCain is invested in this because farmers' successes are their wins too. Now, this whole process has been about learning together for outcomes that impact our day-to-day, but also impact on a large scale. And to ensure impact, we piloted this project with a small group of 5 farmers in North America, and we've been scaling it to all of North America, the farmers that we work with, and hopefully we can scale it worldwide. Now, this project is a multi-year project, right? That's why we needed to ensure that we had stakeholder buy-in from the start. Some of the outcomes that we hope to see are that we see more sustainable agriculture practices. So farmers are able to mitigate losses due to climate change, minimize the resources it takes to harvest. And then for food manufacturers, they have insight into local raw food availability. So then they're able to save costs and time that it takes to outsource more costly product from afar. And then in the chance that contracts are unable to meet demand, at least they have that insight, so then they get early hedging on the spot market. So the tools we developed today, without a doubt, will be completely different in a few years, 5 years from now, be completely different. So that's why we insisted on building our trust early on so that this project can only improve more and more over time. And we at Fiddlehead are committed to supporting farmers, food manufacturers, and FMCG companies in their digital transformation initiatives. And now that we've scratched the surface, what are the possibilities? And I think I have some time for questions, so I'll open it up. There's any.
We got 5 minutes for questions.
5 minutes. Yes.
So, I mean, like this is fine and all, but like how are you adapting like the novel challenges that the farm cannot face before? Like, is it like you want to turn off or you know that we're running out of water, but there are other ones too.
Okay. I'm actually not sure that I follow your question. Do you mind repeating it?
Yeah, so like I feel like aspect one, but like basically what I'm hearing is that this is involves like taking current weather and satellite. Is there that but just like they're always like unexpected that things that most seriously affect farmers and yield. For example, like say there's a big electrical vehicle or like physical field investigation that suddenly like blooms and then you call it one part or workers that think about that or something like that. I mean both little right? Do you like how much use the features like this to put in your model?
Right, so feature selection was done with the great help of the technical team with agronomists. And unforeseen things like bug infestation. We have some data on how the pesticide use affects the soil and affects the growth of potato, and then also affects the environmental impact. But some things are unforeseeable, so those I guess would be new learnings to come in the future. Yeah. Yes.
And what is the system of capturing data? Is it on farmer to
Yeah, so the data sources come from a number of different resources. So yes, certain things like field management practices would come from the farmer, but our weather tool is from a weather API, and the satellite images data comes from satellite image startup, essentially. Yeah.
So, like extreme weather, fires, like all these climate change things that are increasing throughout the decade. So this will anticipate that. So say if a massive amount of rain comes, it would be better harvest now next week to is that part of the
Yes.
program?
Yeah.
Second major objective is to tackle the effects of climate change. So, in addition to the data that we are using some sort of estimate how the temperature might change over time, because these things will change because of global warming. So,
Yeah, so in terms of what we see in the data, of course, because we have years of historical data on weather, like that's where we would see the growth in the increase in average temperature. We also have what I think is really cool, sustainability experts that are in the agronomy field. So they're more focused on like how do pesticide use affect have an environmental impact. It's called EIQ, so environmental impact. Yes, Kosha? Yes. I don't know. I'll fact check that one. Yeah.
First, I just want to say this is amazing that you do this work.
Thank you, I appreciate that.
And I'm wondering, I'm pretty kind of like agriculture industry in general. You mentioned methane.
Yes.
Like a user and a farmer. How do farmers adopt your technology, and like how is that relationship between them and the methane produced again?
Right. So McCain has typically long-running relationships with the farmers that they have contracts with. And then actually, I mentioned in my presentation that there's quite a bit of AI tools in farming. And this one is specific to potato because it's not yet so robust. So potato is actually a rotation crop. So potatoes grown once every 4 years, if done well, once every 5 years. And so farmers actually already have the tools to make efficient, like using AI, other crops in their field. And then when they come to the potato year, like none of these models work. And so that's why we developed this model. Yeah, thanks for the question. Yes.
So is there a main focus just on one zone of farming? Like zone 4B, like potatoes where potatoes grow, or is there any study on zones that are further south?
Okay, yeah, so we have, essentially with McCain, there's farmers all over the globe. So the pilot is North America, and I guess once we expand to other regions, then we'll get more data and insights about how crop grows there and build models there. Yeah. Might be out of time, I'm not sure. And thank you so much everyone for coming, I really appreciate it.